Alright, so today we are going to be learning how to solve systems of equations. You're going to use a few different methods to solve a system of equations, and we'll explain what a system of equation is too, just in case you need a refresher. So learning goals: I can determine the best method for solving a system of equations, solve a system of linear equations using substitution, elimination, and by graphing. Okay? So, systems of linear equations, that's when you have two equations that kind of work together when graphed on the same coordinate plane. So, if you were to take them separately and graph them separately, for example, you'd have the graph on the left here and the graph on the right, and then when you put them on the same one, they would look like that in this particular case. And the solution would be where the two lines overlapped, where they touch. And you write it as an ordered pair. You always write solutions to systems as an ordered pair, your x and then your y. Alright, so there's a couple, or more than a couple, there's three different methods that we're going to focus on today. So one is graphing, and that's best when you're either given a graph, obviously, or if the equations are in slope-intercept form and you're comfortable with going ahead and graphing that. The other is elimination. That one is probably the most common used one, and it's the one that you can use in just about any situation. And that's where you make the coefficients of the variables so that they're opposite, so that when you add the two equations together, you will eliminate one of the variables, hence the name elimination, solve for one, and then plug your answer back in once you get it to solve for the other one. And then finally there's substitution, and that's when you have it set up so that one of the equation has been solved for a variable. In other words, it's going to be like x equals or y equals, as opposed to having x and y on the same side of the equal sign. Alright, so as far as elimination, the goal of it is basically to eliminate one of the variables. Like in this case, we have a positive 2x and a negative 2x, so that when we add these two together, it zeroes out, leaving you with just the y's. Alright. It doesn't matter which variables you eliminate first. You pick one that's the easiest to work with and roll with that. You can get rid of the x's first, the y's first, doesn't matter. As far as substitution goes, the goal is going to be to replace one of the variables in an equation with the expression from another equation, so that basically you'll be left with just a single variable, which in the next problem, the first example I show you today, I'm going to show you one method using elimination. Actually, I'm going to start with substitution and then show you another way using elimination. So let's go ahead and get right into that. So we have the following system of equations, meaning the x and the y variables represent the same thing in these two equations. So the first one I'm going to show you is substitution. Alright, because, and the reason it's best for this is we have this y equals x minus 1. So because we have a y here, and it's all of this equals that y, we can just go ahead and actually plug that in for y up there. Now what you want to be careful of here is, notice it's 2x minus y, so we've got to put that x minus 1 in parentheses. And also notice that we only have the variable x in the equation now, which is good. First things first though, we need to distribute that negative sign across our expression x minus 1. Which leaves you with 2x minus x plus 1 equals negative 7. Combine all the like terms that you can, so 2x minus x is just x. If it helps, think about it like this. You've got 2x minus 1x, which leaves you with 1x. And then we have, so it's basically x plus 1 equals negative 7. Subtract 1 from both sides, which will leave you with x equals negative 8, which is the first part of your solution, your x. We're going to go ahead and then plug that negative 8 back into either one of these equations. I'm going to go ahead and use this one. And it doesn't matter which one though. So if we do negative 8 minus 1, we get y equals negative 9. Now you might say, well, how do I know if that's the right answer? Because luckily there is a way. I can say, I'm going to go ahead and plug negative 8 in for x and negative 9 in for y into either one of these. I'll pick the harder of the two. So 2 times negative 8 minus negative 9 should equal negative 7. So we're not moving anything from one side to the other. We're just going to solve. So 2 times negative 8 is negative 16 minus negative. Okay, so we're basically subtracting a negative, which is actually adding a positive, should equal negative 7, and negative 16 plus 9 does in fact equal negative 7. So it works. Now, just because it worked in one doesn't mean it's going to work in the other, so we want to check that too. So we should plug it in. Negative 9 for y, negative 8 for x. So we have negative 9 equals negative 8 minus 1, which does in fact equal negative 9, so it checks out in both of them. So we're good. So our answer is in fact negative 8, negative 9, and this is how you should write the answer. Just like this. Alright, so this, like I said, this method over here was substitution. Yep, can't spell, sorry. Oh no, I can. Had it right. It's just because I'm writing this way. Over here, we're going to do elimination. Just so you can see it both ways. So the problem with it the way that this is right now is we need to line it up so everything, your variables, your mathematical operator, your equal sign, that they all line up. Right now this doesn't, so we would need to subtract x from both sides. Okay, can't combine a negative x and a y, so it would be negative x plus y. So when we rewrite it, it would look like this. What I like about this is you can draw these columns in, and it'll help make things a little bit easier to look at and manage. So here we have a negative y and a positive y, which when they cancel out will equal 0. 2x minus x is just x, negative 7 and negative 1 is negative 8. So we have x equals negative 8, and now that we have that, we would go plug it in for one of the other equations. I chose the bottom one, so negative x, because it's negative x, and our x is negative 8, so we have a negative out in front plus the negative in here. So that's two negatives, which is going to give us just 8, plus y equals negative 1. Subtract 8 from both sides, you get y equals negative 9, and it exactly matches. So like I said, it's a matter of preference as to which method you want to use. Now if you have a situation like this, where we have coefficients, nothing is like x equals or y equals, you're pretty much kind of have to use elimination to be the easiest method. And what you want to do is you want to choose a variable. It doesn't matter which one. I'm going to go ahead and choose a y. Now remember, you want to make these opposites. So that means that one of them has to be negative when you're done with everything, and one has to be positive. So since I'm choosing my y, the easiest thing to do is to just take the coefficient and multiply the other equation by that, and that's of the variable you want to get rid of. Since I want to get rid of y, I'm going to take my 5 and multiply this by 5. And then do the same thing with the other one. Take the coefficient of the other equation and bring it down. These can both be positive as long as the coefficients that you're getting rid of are opposite signs. If, for example, this was a positive 3y, I would have to make one of these negative so that when I multiplied it out, one of these came out to be negative. I don't have to right now, so I'll just go ahead and multiply everything, not just the left side, but everything by 5. 5 times 3x is 15x, minus 15y equals negative 45. Do the same thing with the other one. 3 times negative 4x is negative 12x, 3 times 5y is positive 15y, 3 times 8 is 24. Now again, just go ahead and make your columns. It'll make it a little bit easier. 15 minus 12x is just 3x. The negative 15y and the positive 15y are going to cancel out. And negative 45 and 24 is negative 21. Divide both sides by 3 to get x equals negative 7. Now you're going to go ahead and you're going to plug that negative 7 into one of the equations just like we did before. I happen to choose the first one, so I'm going to replace that x with negative 7 now that I know what x is. So 3 times negative 7 is negative 21 minus 3y equals negative 9. Add 21 to both sides. You get negative 3y equals positive 12. Divide both sides by negative 3. You get y equals negative 4. And there's your answer. And of course you would check that on your calculator to make sure it works in both equations. Alright, next comes the really easy one, solving by graphing. Alright, so when you're given a graph, all you have to do is look and see where the lines cross. That's it. If you're given two equations that are in slope-intercept form, you can just go ahead and graph them and then look where the two lines cross. So we want to identify the solution for the graph below. There's where the two lines cross. I'm going to follow my x up to the point, which is 5, and my y over, which is 4. So my solution is 5, 4. And if I wanted to, I could say, okay, so 4 times 5 minus 6 times 4 should equal negative 4. 20 minus 24 should equal negative 4. And it does. So it checks out with this equation over here. Then I plug it into my other one. 8 times 5 plus 2 times 4 should equal 48. 40 plus 8 should equal 48. And it does. So it checks out in both. But with a graph, it's kind of hard. You don't need to check as much if you're given a graph. If you're drawing a graph, I would definitely check just in case one of your lines was off by a little bit. All right, some tips. When you have to multiply an equation to use elimination, make sure you multiply all the terms in the equation. So in other words, both sides of the equal sign. And then finally, do not forget to check your solutions to make sure they work in both equations. This is one of those unique situations where you will know if your answer is right or wrong if you actually check your work. So that's all I have for you. We will be spending some extra time on this, so if you have any questions, please ask them in class and we will get them cleared up.